Can we solve a system of equations? What are our choices if you're asked to solve a system of equations? Substitution, addition, graphing, and the inverse matrix, right? The one we just learned in section 12.4. So obviously, that's just not enough. You need at least one more. The nice thing about what we're going to learn in section 12.5 here is that it helps fill in a little bit of a gap as to why in section 12.4 we couldn't find the inverse matrix in one situation. And it's called Cramer's rule. Now, in order to do Cramer's rule, I first need to teach you how to calculate what's called a determinant. So we're going to look at calculating determinants in the 2x2 case and then the 3x3 case. I will work to make these problems sufficiently easy on an exam. Let's start with a 2x2 determinant. So 2x2 determinant, determinant, looks like this. Instead of brackets like you would have around a matrix, you're going to have you're going to have what looks more like an absolute value here. Now, the calculation to determine it is pretty simple. It's just the product going down, so A times D, minus the product going up, which is C times B, although traditionally we write it in alphabetical order, B times C. Let's practice a couple simple ones to get started, like problem number 18. -1, 2, 3, and -4. So the author, in a burst of creativity, comes up with this challenging problem here for us. Let's see if we can come up with our answer. Now the product going down is going to be -1 times -4 minus the product going up, which is 3 times 2. What do I get for my determinant on this one? Kara, want to simplify that one for me? Perfect. So there's your determinant, -2. Determinants can answer a lot of questions. We'll use it in this section to answer questions about a solution to a system of equations. But other determinants can find like the area of a triangle and a lot more. Let's try problem number 20. And thanks, Kara. 10, 15, 15, and 5. So again, it's a product going down minus a product going up. Product going down is 10 times 5 minus a product going up, which is 15 times 15. 15 times 15, you can check it on the right-hand side board, is 225. Pardon me, other right-hand board. My right hand, your left hand. You're -175 for the determinant here. How does this tie into systems of equations? Well, there's a rule called Cramer's rule. That's going to allow us to solve systems of equations pretty much mechanically. Cramer's rule for systems of equations is like the quadratic formula for the quadratic equation. It's just a plug and chug way to solve a system of equations. So let's see Cramer's rule in the 2x2 case. The 3x3 case, I'm not going to write it down. So try and catch the pattern here. AX plus BY equals C. DX plus EY equals F. So this is a very general 2x2 system of equations. I haven't told you what A, B, and C, D, E, or F are. But I can write down the solution to my system of equations. So I'm first going to calculate 3 determinants. And it's going to start with D, the matrix of coefficients on the left-hand side. So that would be A, B, D, and E. Now the important thing to catch next is the pattern. What pattern do I use to come up with the next two matrices? Well, what we're going to do is one at a time take the numbers on the right-hand side and replace these columns in D. So I'll start with C and F, but I'll keep B and E. And then for the next one, I'll keep A and D, and then I'll put in C and F. So one at a time, you replace first the first column and then the second column. First the coefficients of x, then the coefficients of y to get these two remaining determinants. I'll call them dx and dy. Dx you get by replacing the coefficients of x, dy you get by replacing the coefficients of y with the right-hand side. Please don't stop here. That's not a solution. You still need to solve for x and y. So x is dx over d, and y is dy over d. There's your solution. Yay. So, how does that look in practice? What would it look like for a system of equations? Well, let's pick one. Let's pick problem number, I'll let you choose, 44 or 46. 46 has some kind of ugly looking numbers. Maybe you'd want something mechanical to do problem 46 with. It's a good meaty problem. Let's work on 46. (5x plus 3y equals 72). 3x plus 5y equals 56. Not exactly a really friendly problem to solve by hand. You could use elimination or substitution. Substitution would require using fractions. Elimination would require multiplying both equations by something and then adding them together. So, all right, let's give this Cramer's rule a shot. We're going to start out with D, the determinant of the matrix of coefficients. What numbers go into D? Five, 3, 3, and 5. Now let's not worry about calculating that stuff just yet. Let's come up with the next two matrices, dx and dy. So one at a time, we're going to replace the columns here with this column here. So for the first matrix, I would have 72 and 56. Lauren, what else would go here? 3 and 5. Good. 3 and 5. Good. Thank you. And then for the second one, come. What would I have here? What do I? 5 and 3. And then what? 72 and 56. Great. So we got a little bit of work to do. Thank you both. Here we get 25 minus 9, which would be 16. Product going down here is 360 minus a product going up, which is 168. 192. Thank you. So 192. And then product going down is 330 minus product going up, which is 216. Oh, okay. Yeah, I was gonna say, wait, the difference here is like what, 114? Is that right? That's just, something doesn't seem right. 330 minus 3 times 72. Yeah. Oh, okay. All right. Yeah, thank you. 280. All right, so 280. Okay, so yeah, that's 64. Perfect. We're not quite done, but we're pretty close. To get x, I'll calculate dx over d, and y is dy over d. So that would be 192 divided by 16, I think that's 12, and 64 divided by 16, I'm certain is 4. So there's your solution. Kind of a mechanical approach, but, you know, a workable solution nonetheless. Where's there? This is 16? Oh. Sorry. Anything else on problem number 46 here? Can you set these things up? Let's try a different one. Let's take a look back at problem number 34 from the previous section. And that problem looked like this. Negative 6x plus 12y equals 10. And 2x minus 4y equals 8. What I'd like you to do, and I'll kind of walk around and try and help out, is set up the matrices here. D, dx, and dy, and take the determinants of those. So d, dx, and dy. So find those determinants. And that's really all I'm looking for you to find right now. We'll discuss the solution in a second. Let's set up those determinants. That's quite likely part of what I'd ask you to do on a problem with Cramer's rule is just to set it up. the screensaver shuts off here, does the screensaver also shut off on the video? No, it doesn't. It just keeps rolling. Okay, thanks. It's a minus 24 minus 24. Okay, so let's see how we're doing on this one. Our coefficients should look like this: -6, 2, 12, -4. Over here, well, one at a time, we need to start replacing these columns with this right here. So maybe we could put a 10 and 8 here, and then a 10 and 8 here. The rest of this would be 12 and -4, and then -6 and 2. Let's calculate some determinants. I'll start from right to left. I get -48 minus 20 is -68. -40 minus 96 is -136. But had I started left to right, I wouldn't have gone any further. -6 times -4 is 24, minus 24 gives me 0. Why should I have stopped if I got a 0 right away? You can't divide by 0. If you remember in the last section, if you wanted to look back at the last video, when we did this problem, it said you couldn't find the inverse matrix, could we? And that's always going to be true if the determinant here is 0. If the determinant is 0, all bets are off. It's either inconsistent or dependent, one of those two. But once you see that determinant is 0, then, okay, you know that it's not going to be a nice, neat solution. You're not going to get one point like we do for a lot of these problems. It's going to be something else. So it's important to know that a determinant is something other than 0. So let's see. I'm not sure if it said that or not when we tried to take the inverse. Yeah, no inverse matrix exists. It calls it a singular matrix. So it's singular, that corresponds to the determinant being 0. Now, do you like using the calculator for some of these things? Like in the last section, was that a good thing? Yeah. All right. I'm going to do you guys another favor. And I don't think I've ever shown this to a math 1150 class. But we're going to do this stuff for 3x3 system equations. So let's do the setup part first. And I'm not going to go through and write it out in general detail like I did with the 2x2 case. So 3x3, Cramer's rule. And let's see if we can't pick a kind of a nasty problem for Cramer's rule in the 3x3 case. Now, they don't really give us one. All right. Probably as ugly as they get. It's not really all that ugly. It's problem number 53 or 54. Since 53 is one of your homeworks, let's do problem number 54. x plus 2y plus 2z equals 10. 2x plus y plus 2z equals 9. And 2x plus 2y plus z equals 1. Now, Cramer's rule for the 3x3 case works pretty much just like it did for the 2x2 case. It just got a little bit more stuff to deal with, that's all. So for starters, I'm going to start out with D, which is the determinant of the matrix of coefficients. What stuff do you think I should put in for D? 1, 2, 2, 2, 1, 2, and 2, 2, 1. Are we okay with what we put in for D? Do you see where that's coming from? We're going to do kind of the same game here that we did in Cramer's rule in the other case. I need dx, and then dy, and then dz. So as far as dx is concerned, anyone want to take a stab at dx? I mean, I know I haven't mentioned it yet. Want to take a stab at dx? What should the first column of dx be, do you think? 10, 9, and 1. In fact, let's take that 10, 9, and 1 and do this. I'm going to write it in the first column, and then in the second column, and finally in the third column. 10, 9, and 1. Now the rest of the matrices should be the same as it was in D. So just fill in everything that already isn't filled in from the rest of your matrices. So 2, 2, 1, 2, 2, 1, 1, 2, 2, 2, 2, 1, 1, 2, 2, 2, 1, 2. Okay. Can anyone see a problem with Cramer's rule right away? What's one of the problems with using Cramer's rule? It's a lot of work. You guys don't even know yet how much work it is to calculate a 3x3 determinant by hand. But you're not going to experience that, at least not today, because I'm going to show you how to do it on the calculator. So let's enter matrix D, or let's enter these numbers into matrix, or a matrix, we'll call it matrix A, and then see what we can do from there. So second, and then the x inverse key to enter that matrix. So edit. What size matrix should I set up? 3x3, 3 rows, then 3 columns. Let's type in 1, 2, 2, 2, 1, 2, 2, 2, 1. With that entered, you should exit. So hit the second button and then the mode key to quit. It's not a bad idea to go back to the matrix menu. So press the second key and the X inverse button, and press enter twice just to type out your matrix and see what it looks like. Make sure that you entered it correctly. Okay, so we got it correct. That's great. Let me clear that. What I wanted was the determinant here, right? So let's go back to the matrix menu. Second matrix. This time, let's go over to the math menu. Does there look like there's anything promising that would help us out in the math menu? Yeah, the first one. Boom. Booyah. So press that, but it needs to know what to take the determinant of. What could it take the determinant of? What should we take the determinant of? Matrix A. So go second, and then matrix, and then select the first one. Take the determinant of matrix A, and you'll get 5. Yay. So the determinant there is 5. Now, what you should do is go back and edit things to get this determinant. Now let me show you some tricks to help you make this a little bit faster. So let's go to second and then matrix, and we're going to edit matrix A. The only thing we need to change is the first column. I want 10, 9, and 1 in the first column. That's it. That's all I'm changing is the first column. So hit second, then X inverse, go to matrix A, or actually go over to the edit column, then choose matrix A. Once you've made these changes, hit the second button, then the mode key to quit. Now we need to type in matrix A again. Here's a shortcut. I've already got the determinant of A that I just calculated, right? So I just need to issue that command again. Press the second button, then the enter key, and it'll bring up your previous calculation. Ooh, that's cool. We're going to have to go chasing through all those menus again. Just press enter, and you get negative 10. If we did likewise for dy, you would get negative 5. And for dz, you would get 35. Finally, x is dx over d, which is negative 10 over 5, or negative 2. Y is dy over d, which is negative 5 over 5, which is negative 1. And last but not least, z is dz over d, which is 35 over 5, or 7. So overall, your solution is negative 2, negative 1, and 7. It's too long of a problem to ask you on an exam, and it serves no point for me to ask you to set up and calculate 4 3x3 determinants. Cramer's rule, in my mind, has one good purpose, and it's building a connection between determinants and matrices and systems of equations. It also, I guess, serves to tell you when you can find an inverse matrix. So this is the one last thing I want you to know for the exam. A inverse exists when determinant of A is different than 0. So there's an exam question for you. When does A inverse exist? Actually, when the determinant of A is different than 0 is when it exists. But as far as a test question is concerned, typically what I'll do for this is I'll give you the system of equations, and I'll give you, say, d, dx, and maybe dz. I'll give you 3 out of the 4 of these values. So the only thing I'm expecting you to be able to do is set up, whichever determinant I haven't given you, and then finish the calculation. So really, I'm only asking you to do one 3x3 determinant, and even then I'm letting you use the calculator. So it's a lot nicer than those who have gone before you have had it. But is there any question about what I expect? You should be able to take this system of equations, and depending on what I give you, set up the missing matrix, find its determinant, and then finish its solution, x, y, and z. Of course, you'll have all that. You have most of it. You should be able to finish your solution this way. For homework, try 17 through 23. That's just some practice with 2x2 determinants. 43 through 47 is some practice with, let's see, solving systems in a 2x2 case, and then 59 and 61. Okay. Test will be on Wednesday. We'll cover up to and including section 12.5. So it'll go from 11.7 to 12.5.